So let's see how we did on this one. Now remember from last class, when we see the equal sign, we can work on each side of it separately while we're reducing and combining things. So on the left side here, what would we do first? Okay, we see the parentheses, and that should always scream at us to start here. And in the parentheses, we always first look to see if there's anything to do in the parentheses. Well, in this case, there's not. So then the second question is always, is there anything to do to the parentheses? Yes, sir. Oops, sound isn't working, is it? Is that better?
No, it is.
Okay, thank you. I keep forgetting that every time the system shuts down, it automatically mutes itself. Sorry about that. So anyway, we're starting on that left side, and we see the parentheses, and there's nothing to do inside of them, so then we're going to have to distribute that 7. So 7 times 2x gives us 14x, and then 7 times 5? 35. Good. And then we have the minus 4x here. Is there anything more we can do on the left side before we move to the right side? Okay, 14x, and that's a negative 4x, make 10x. Good. So it's 10x plus 35. On the right side, what do we need to do? Okay, it's a similar thing. We see the parentheses, and again, there's nothing to do inside the parentheses. So we look outside, and it is being multiplied by 5. So we're going to distribute the 5. 5 times 6x makes 30x. Then this is a 5 times negative 3, which makes, careful, positive 5 times negative 3 is negative 15. Good. Then a positive 4. And we can combine. Is there anything to combine with the 30x? Nope. Negative 15 and positive 4 make? Perfect. Negative 11. Now we've reduced everything we can on each side, but there's still a variable on both sides. So we have to get rid of one of them. Which one are we going to get rid of? The 10x. That's gone, leaving us with 35 here. But we have to take 10x off of the other side as well. It'll come from the 30x. 30x minus 10x is 20x. And then? Okay, now we just have the single variable appearing on one side of the equation. So we're going to get rid of everything. We're going to add the 11 to get rid of it. Adding 11 over here makes 46. And finally, divide by 20. Good. So that gives us 2.3 equals x. How many of you had that? Just a couple? That's a start. We'll go over more of those as we go on. Just a note before we get into the new material for tonight. This is wrapping up Unit 1 tonight, which means next week, Tuesday night, is going to be our Unit 1 test. Now, especially for the first test, I usually allot the full 3 hours. So we'll get started on it and have the whole class to work on it if you need it. The first test, most people don't go over an hour and a half. But there's always a few that need a little extra time. So we'll make sure it's plenty of time for you. Now, if you have a gap between classes, if you want to come in early and start the test early, we should be able to do that. My classroom next door should be empty by that time. So I can, if you're here in Rice Lake, I can put you over there. In New Richmond, if you want to take it early, you'll have to stop in at the ITV office and get it from them. They should have it. Or talk to them first. They may send you down to the teaching assistant in the LRC to work on it there. Otherwise, if you take it in class, they should have it in the classroom ready for you when you get there.
Who are we supposed to give it to? Because let's say we don't get done with it until 7:30 and everyone's gone already.
If everybody's gone, it should be sitting in the classroom when you get there in a folder. You just put it back in the folder and leave it there, and they'll pick it up in the morning. How many questions is it? That's a good question. This one is actually 40 questions this time around, I believe. Actually, no, 50 on this one. On this one, you can use your. I'll trust you not to cheat if you have to use your phone as a calculator, but I'd prefer you have a regular calculator. It works better anyway. But you can use your books and your notes on this test and your calculators. Any other questions on the test? No, just because the internet capable, the search capable. I know phones can do that too, but. Any other questions? Okay, we'll make sure we have at least some time at the end of class tonight to go over the test and make sure you know all the topics that are on it so you're not surprised. Okay, so our new stuff for tonight. What we're going to look at tonight is actually a little bit of a step back away from the algebra, looking at using one of our more practical applications of numbers, which is a percent. A large portion of units 2 and 3 of this class depend on percents. To understand percents and how they work, we first must understand the word percent. And it's actually two words, per. Think of miles per gallon or miles per hour. It means for each or out of. And cent. Think of years in a century or cents in a dollar. It's 100. So if I give you a number like 38%, that literally means 38 out of 100. As we're manipulating our percents, one of the first things we need to be able to do is to convert from percents to decimals to fractions and back again. Because different calculations we do are going to require us to have them in different forms. And to convert from a percent into a fraction, it's actually just as easy as what we did right here. 38% becomes 38 over 100. Any percent is just over 100. Now we're not going to leave it like that because it can be reduced. 38 and 100 can both be divided by 2. 38 divided by 2 is 19. 100 divided by 2 is 50. So as a fraction, 38% is 19 out of 50. So if I had 65%, what's that going to become as a fraction? Well, first it'll be 65 over 100. And what can we reduce that by? 5. Very good. 65 divided by 5 is 13. And 100 divided by 5 is 20. Now, those of you that learned how to use the fraction function on your calculator, once you get to this point, 65 over 100, you can just use that fraction key on your calculator as well. Just enter 65 ABC 100 and it will reduce it to 13/20. How about 284%? What's that going to become as a fraction? Well, just like any other percent, it is out of 100. So 284 out of 100. Now, of course, you notice that this is an improper fraction. So we could approach it. We could either change it into a mixed number first, or we could try to reduce it first. I personally would change it into a mixed number first just to get some smaller numbers. Especially since it's easier with 100 anyway. How many times does 100 go into 284? 2 times would be 200 with how many left over? 84 100ths. Perfect. Now I can reduce the 84 over 100. Both of those can be divided by, well, they're both even, so we can divide by 2. That'd be 42 over 50. Are we done? No, they can both still be reduced by 2, giving me 21 over 25. Is that the answer? What am I forgetting? The 2. 2 and 21 25ths. Perfect. How about 18 and 1/3%? It's still going to be 18 and 1/3 out of 100. Now, we don't like having fractions within our fractions. So obviously we have to get rid of that 1/3 somehow. To get rid of a fraction, usually we just multiply by its denominator. In this case, it's a 3. So I'm going to multiply this on top and bottom by 3. So 100 times 3 is 300. 18 1/3 times 3 is going to require a little bit more work. So it's going to be 3 over 1. What do we have to do to the 18 1/3? Make it into an improper fraction. How do we do that? 18 times 3 is 54, plus 1 is 55. Good. Now we can cross cancel the 3's. So we got 55 over 1, or just 55. So on top, this is just 55 over 300. And of course, now we can reduce that by 5. 55 divided by 5 is 11. 300 divided by 5 is 60. So 11/60ths. How about 37.5%? Perfect. Just like any other percent, it's 37.5 over 100. But we don't like having decimals within our fractions either. To get rid of a decimal, we multiply by 10 or 100 or whatever we need, depending on how many decimal places we have to get rid of. This only has one decimal place, so what do we need to multiply by? 10. Good. So 37.5 times 10 is 375. 100 times 10 is 1,000. That can be reduced by 5, okay. 375 divided by 5 is 75, I believe, correct? 1,000 divided by 5 is 200. We can still reduce by 25, I heard somebody say back there. 75 divided by 25 is 3. 200 divided by 25 is 8. So 37.5% is 3/8 as a fraction. So I want you guys to try 12.5%, convert that into a fraction, and 56.25%, convert that into a fraction. Let's see how these went for you. So 12.5% is going to become 12.5 over 100. Now some of you may have chose to convert that into 12.5 and go from there, which would be a lot easier way to go about it. That's probably how I would have done it if I was doing it myself. But let's treat it as a fraction. Let's keep it as a fraction for now. How would we get rid of the fraction? Multiply everything by 2, because we have a denominator of 2. That gives us 100 on bottom. On top, that would be 25 halves times 2 over 1, which is going to just give us 25. Oops. I don't get 100 on bottom. What do I get on bottom? 200. 100 times 2 is not 100. Okay, so then what do we do? Divide by 5 will be a start. Gives us 5 over 40. And then divide by 5 again to get 1/8. Yes, you could have divided by 25 at first if you wanted to. Next, 56.25% becomes, well, we started as 56.25 over 100. And then, since there's 2 decimal places, we have to multiply by 100 to get rid of it. So it's 5,625 over 10,000. Now Now, I wouldn't blame you if you chose to use the calculator to reduce that because it is kind of ugly. But let's pick away at it. We can divide both of those by, we'll start with 5. So 1,125 over 2,000. Still divisible by 25, I heard somebody say. Which is going to give us what? Is that 45 over? What do we got down there? 80. There we go. Thank you. 45 over 80, and still divisible by 5 again. Give us 9/16. Any questions? Okay. Well, our next conversion is quite a bit easier. If I want to go from a percent into a decimal, 38%, as we said before, is just 38 over 100. Rather than reducing that fraction, we can just turn it straight into a decimal by dividing it out. 38 over 100 can be turned into a decimal by doing 38 divided by 100, which is 0.38. Any percent converted into a decimal is going to be divided by 100. 71%, 71 over 100, or 71 divided by 100, or 0.71. As we saw up above, we could multiply by 100 to move the decimal point. Dividing by 100 just moves the decimal point 2 spots. So the shortcut to get from a percent into a decimal, we know we're dividing by 100, the decimal point just has to move 2 places. So if I have 68%, what is it going to become as a decimal? 0.68. If I have 9%, what is it going to become as a decimal? 0.09. 240% will become, well, 2.4, yes, 2 4/10. 2.2%. Perfect, 0.032, good. The decimal point still just has to go 2 spots. Let's throw in 0.032, good. How about 19.5%? If we make it 19.5, it's still a percent. The decimal still has to move 2 spots to make it 0.195. Here's the one I always get people on. Convert that to a decimal. Perfect. Most people want to jump at 0.25, but that would still be 0.25%. To change it into a decimal, it's 0.25 over 100, or 0.0025 as a decimal. Let's go the other direction now. Going from a decimal back into a percent, of course, we're just reversing the process. The reason for that, of course, 0.31, you would just multiply by 100 to make it 31%. The reasoning behind that is a decimal is out of 1. 0.31 is considered to be out of 1. A percent is always out of 100. So to convert from out of 1 to out of 100, we're multiplying by 100. Give us the 31 out of 100, or 31%. Again, for our purposes, we can just move the decimal point back those 2 places. So if I have 0.41, what is that as a percent? .41, there we go. 0.2 becomes 20%. 7.1 becomes 710.093 will become 9.3%. 2.59. Perfect, 259%. So enough of just converting with the decimals. That's a pretty easy conversion. When we get back to the fractions now, that can be a slightly more difficult conversion. Let's start with one that most of us know off the top of our head. 3/4 becomes what as a percent? 75%. But what if we didn't know that off the top of our head? Well, we could have just divided 3/4 to get 0.75 and move the decimal point. That works just fine. But sometimes we run into ones that don't work quite so simple that way because they don't turn into neat decimals. 1/3 divides out to be 0.33333. It's not such a neat decimal. We can set it up as a proportion like we discussed last week, and to find that missing number in the proportion, we can cross multiply and divide. 1 times 100 is 100. And then what do we do with the 3? We divide by 3, which is going to give us 33.33. We're going to still have to round it off at some point, percent. So let's convert 3/7 to a percent to the nearest 10,000. Nearest 10,000th percent. So 3 out of 7 is going to be how much out of 100? 3 times 7 is 300. Divided by 7 will be, what was that? 42.57. No, that's wrong. 857. Thank you. 85714 approximately. I had to go one extra digit so I can round to the 10,000th. 42.8571%. Let's have you guys try a couple. So we convert 5/8 into a percent and 7/11 into a percent to the nearest 100th of a percent if needed. So 5/8 becomes what percent? Five times 100 is 500 divided by 8 is 62.5. So 62.5%. How about 7/11? 7 times 100 is 700. Divided by 11 is 63.64 or 63.64% to the nearest hundredth. Any questions on those? Okay. So let's look at our basic calculations. We can start out, oh, let's just use some simple sentences here. Blank is 60% of 90. So we've seen in these problems the percent is always out of 100. And when I'm setting up any percent problem, whether it's a simple problem like this or a word problem, I like to start with the percent. 60% is 60 out of 100. Then I match things up with those numbers. In this problem, there are two other numbers. There's our missing number and there's the 90. We have to figure out which one of them matches up with the 60, which is our percent, and which one matches up with the 100. Now, the 100 can also be thought of as a percent. 100% is the whole thing, or a starting value, or initial value. So in this case, it's pretty obvious blank is 60%. So that missing number matches up with the 60. Of 90, you can think of that almost as out of 90, which tells us that 90 has to go on bottom. So to find our missing number, we'll cross multiply. 60 times 90 is 5,400. And then divide by the 100 is 54. So 54 is 60% of 90. What is 120% of 40? Once again, I like to start out with a percent. So 120% is 120 over 100. On the other side, again, we have two other numbers. We have a missing number. Instead of a blank, they have the word what in this one. And we have the 40. Which one matches up with the 120? What is the 120? We're looking for the number that matches up with the 120. Of 40 goes on the bottom. So we're going to cross multiply and divide. 120 times 40 is 4,800. Divided by 100 is 48. So 48 is 120% of 40. Now, if you think about that, it makes sense. 120% is more than 100%. 100% is the whole thing, so 120% has to be bigger than what we started with. So 48 is bigger than 40. 48 is 120% of 40. We try 30% of 250 is blank. This one's worded a little different, but it still sets up the same. I have the percent. 30% will be 30 out of 100. And once again, I have a number and a missing number. I have the 250 and I have a missing number. Which one matches up with the 30? Because of the way this problem is set up, it's a little harder to analyze. But what I do is I cover one of them up. Let's say I cover up the blank here, the missing number. I read 30% of 250. That doesn't quite seem to go together. So let's try it the other way. I'm going to cover up the 250. 30% is blank. That makes more sense. So my missing number, the blank, matches up with the 30. 250 goes on bottom. Now, some of you in a high school math class or in another math class may have heard the phrase is over of. In simple sentences like this, that's usually true. The number that is with the is goes on top. The number with the of goes on bottom. I caution a little bit against that because once we get into regular word problems, those cues may not be true. So be careful with it. So anyway, here we're going to cross multiply and divide. 30 times 250 is 7,500. Divided by 100 is 75. So 30% of 250 is 75. We'll shift gears a little bit here. $32 is blank percent of 40. Now, I said on the last few problems, I always like to start with the percent. Here, I don't have the percent. Doesn't mean I can't start with it. The missing percent just becomes blank over 100. And I'm going to match things up over here just like I did before. 32 is blank percent. So 32 seems to match up with our missing percent. Of 40, again, think of it as out of 40. So we'll cross, multiply, and divide again. 100 times 32 is 3,200. Divided by 40 is 80. So 32 is 80% of 40. $78 is what percent of 60? So once again, we're missing the percent. Blank out of 100. On the other side, the 78 or the 60, which one matches up with the missing percent? $78 is what percent? So 78 matches up out of 60. So again, we'll cross, multiply, and divide. 100 times 78 is 7,800. Divided by 60 is 130. So 78 is 130% of 60. Blank percent of 90 is 18. So again, we'll set this up, missing the percent, so it's blank over 100. On the other side, again, we have the 90 and the 18. Which one's going to go on top? The 18, good. If I have to cover one of them up, when I cover up the 90, I read blank percent is 18. We see that the missing percent matches up with the 18, the 90 on bottom. We'll cross, multiply, and divide. 100 times 18 is 1,800. Divided by 90 gives us 20. So 20% of 90 is 18. Let's shift gears once again. $45 is 90% of blank. Well, here we have our percent again, so we're going to start with that. 90% is 90 out of 100. Now again, we have two other numbers. Here we have the 45, and we have the missing number. Which one goes with the 90? 45 is 90%. So the 45 goes with the 90. The missing number goes on bottom. So 100 times 45 is 4,500, and divided by 90 is 50. So 45 is 90% of 50. %70 of blank is 49. So once again, we have the percent. We'll start with the percent. 70% is 70 over 100. On the other side, we have the missing number, and we have 49. Which one goes with the 70? $49, perfect. If we cover up our missing number, 70% is 49. Makes sense. The 49 matches up with the 70. So our missing number is on bottom. And we'll cross, multiply, and divide. 100 times 49 is 4,900. Divided by the 70 is 70. So 70% of 70 is 49. Now, I solve these using proportions. Many of you may have learned a different way of doing percents in earlier classes, something called the rate method of percents. But the rate method of percents it involves turning a percent into rates. And all the rate is the decimal equivalent of a percent. So 80% gets turned into 0.8, and we work with it that way. Now, throughout units 2 and 3 of this course, we are going to convert a lot of our percents into decimals and use them as rates, just because there's formulas that we work with that require them to be as rates. They ask for the rate, not the percent. But for these basic percent problems, I find it's a lot easier to use the proportion than it is to use those rates. For example, if I go back up to our first problem we did here, if I were going to use the rate method on this, 54 is 60% of 90. I would take the 60% and I would convert it into 0.6 as a decimal. Now I'd finish that problem off by doing 90 times 0.6 is 54. We get the same answer, which would be better. And this actually seems a little bit easier there. In fact, if I looked at the second one, we're at 120%, which becomes what as a decimal? Moving the decimal 2 spots, 1.2. So we would take 40 times 1.2 is 48. Again, the same answer, and it seems a little bit simpler. But the reason why I don't use that method so much is when we get down to problems like this one. Here, 45 is 90% of, well, 90% as a decimal is 0.9. But I'm not going to do 45 times 0.9 to solve this. We would have to do 45 divided by 0.9 to get 50. So if you're using the rate method, you have to not only convert the percent to a decimal, but then you have to figure out whether you're going to multiply or divide. In fact, there's a third type, which is this one, where we're looking for the percent. To use the rate method, this would be 18 divided by 90 is 0.2. Then we'd move the decimal at the end to get 20%. Now, if that is the way you were taught and you like doing it and you're good at it, that's fine. Keep using it. That's the way I was taught, and to be honest, there are a lot of times I use that because it's quicker to do it that way instead of going through the proportion. But for most of our basic problems, the proportion is easier and produces fewer mistakes. And when we hit some of our basic word problems, that proportion works really well. For example, I'm going to be really creative with my names. For X company, profits are 28% of gross revenue. In a quarter, where profits are, let's go $58,800. What was gross revenue? Well, first of all, here we do have a percent. We have the 28%. So it's 28 over 100. In a word problem, I like to label things. We've already seen on the proportion, what's on one side of the proportion has to be linked to what's on the other side. So whatever goes over here has to be connected to that 28 somehow. But what does that 28% represent? Well, profits are 28%. That represents the profits. Then the 100% has to represent some sort of a base amount, the whole amount or a beginning value. In this case, the only other value represented here is the gross revenue. The profits are a portion or a piece of the gross revenue. So the gross revenue is the whole amount. So the 100 represents the gross revenue. So on the other side, all we have to do now is match up the numbers that also represent the profits and the gross revenue. Well, we have the 58,800. Does that represent profits or gross revenue? Profits are 58,800. So that is going to go on top. Our missing number is the gross revenue. We're looking for the gross revenue. So we are going to cross multiply and divide. 100 times 58,800 divided by 28, which is going to give us what? $210,000 for our gross revenue. Any questions? Okay. Now your book uses a graphic for percents, not one that I particularly care for. But what your book does is this. It defines something called a base, a portion, and a rate. I'm never going to require you to know those terms, but if it's a way you prefer to do it, again, feel free. And what the book uses is a graphic that looks like this. It has base times rate on bottom and the portion on top. The base is generally whatever represents the 100%. That's that initial amount or that whole amount. So if we had, I'm just going to throw a simple word problem out here. Blank is 70% of 30. Of 30 is the out of. If we're looking at our percent proportion here, percent over 100, the portion is this top number on the other side, and the base is the bottom number on the other side. So the 30 would go on bottom, that becomes the base. The 70% has to be turned into a rate, which would be a decimal of, bless you, a 0.7. And what we're looking for here is the portion. So you'd cover up the portion. The base is 30 times the rate of 0.7 gives you 21. I don't particularly like that method, so I'm not going to use a lot of examples of it. I just wanted to point out to you that it is in the book. If you're confused with the ways I've shown you, you can try that. If you have questions, let me know and I'll go over them with you. But like I said, if you don't ever use that again, I won't be terribly disappointed in you. That's a good spot to take our break. It is about 6:17, 6:18 right now. Let's come back at 6:28 and we'll start lecture again.